Well, good day. My name is Sandy Johnson. I'm with Kansas State University, located at the Northwest Research and Extension Center in Colby, Kansas. And this morning I was talking about really our reproductive technologies that we have available to us now and some of the ways that we see them developing over time. And the thing that we're going to notice is really the combination of what we're learning about genomics and combining that information with our reproductive technologies. And I think what we'll see is we're going to have increased rate of genetic change than what we've seen before. You know, when we run a genomic test on an individual, it's like getting, depending on the trait, anywhere from like 15 to 30 offspring, information from those offspring before the animal may be even old enough to reproduce. And you really see the dairy industry leveraging this so that they're collecting oocytes from very young animals. As soon as a bull calf is able to produce any viable sperm, they're using that, and they're really reducing the generation interval. And so the average age of current parents in the dairy industry is about half of what it was, say, 10 years ago. And when we look at what determines genetic change, the average age of the parents is a key portion of that. And so as we look at making change, we may be making some changes that are wrong, and those will happen more quickly. So it's going to behoove us to think things through, the types of things that we want to do to improve our cow herds and markets that we want to reach. Now, we have a variety of assisted reproductive technologies, and sometimes you hear them referred to as ART. AI is kind of the base of that. Embryo transfer, in vitro fertilization, and cloning are all in that same category of assisted reproductive tools. And essentially our ability to use embryos, whether they're produced in vivo or in vitro, we're going to generally use our estrous synchronization techniques to put those back into recipients. And when we think about these technologies and all the things that we can do, the changes may be greatest in our seed stock and more elite herds, but if we're using artificial insemination, we're going to have access to those tools, and some of the changes and opportunities are there much sooner. So that's really an advantage for those that are using AI now and working on those, the things they're going to be able to access in the future. Now, when we think about cloning, you may remember back in 1986 when Dolly the sheep was born. That was essentially the first clone farm animal that was produced. We still have relatively low efficiency of production of clones. We're essentially taking a somatic cell from an elite animal. We culture that and end up putting that in an enucleated oocyte from a donor female, grow that embryo a while, and then put it in a recipient, much like any other embryo transfer. And the advantage of that then is if we have a very elite individual that perhaps dies young, we can still collect tissue, say, from that elite bull, and are able to culture it and preserve those genetics. This is another thing that we can do with it is our geneticist friends are looking at finding mutations that occur in one breed or type of animal. For example, in Holsteins, we know they have horns. It's expensive, problematic to dehorn them. If we could do that genetically, would be great. So they've taken a pole gene, put that in Holstein animals to have naturally dehorned Holsteins. All right, so using that same concept then, we can find animals that are more resistant to pests, heat. There may be other traits that relate to water use or feed efficiency that the geneticists are looking at, essentially moving some of those traits from one place to another, from one animal to another, so that we can produce, whether it's more polled Holstein bulls or heat-resistant Angus cattle, looking at those types of things. So as the geneticists work on that, then we'll use probably cloning to create more of those animals quicker to be able to utilize those genetics more broadly. Another very interesting part of our assisted reproductive technologies, we've looked at trying to use sex semen, for example, to create F1 females. We know for many of our commercial producers, whether it's a Bos Indicus, Bos Taurus crossed in the south, or a Hereford Angus cross in the Midwest, it's hard to beat those F1 females for commercial production, then mate them with a good terminal sire. But creating those F1 females is a little bit problematic and challenging. And so what we might be able to do is actually create those F1s via embryos, and rather than trying to AI with sex semen, we're just going to put in an embryo that's already the F1 of the gender that we want to create those. So we have opportunities like that as we try to put some of these technologies together. The future is really exciting. We will certainly have to deal with some concerns from the human population, because the technologies that we use in animals can generally be done in humans as well, and some of that can be kind of scary. As a scientist, I feel like most of scientists are looking at using those tools for improving mankind, but we certainly can't promise that there won't be others with other purposes in mind. So exciting time to think about all the opportunities, ways to combine some of these tools. We'll certainly have to test them in our production systems, because often as we think about making a change, we think we're only changing one thing, but we might end up changing something else in the system. And so hopefully we don't have too many hard knocks in learning those lessons, but certainly have to look at our entire production system as we go forward. If you raise replacement heifers and you're trying to really target in on those heifers that will have the best response, a great tool for you to use is a reproductive tract scoring system. And it's a 1 to 5 scale, essentially trying to evaluate how physiologically mature those heifers are, and probably importantly is to note those fairly immature heifers that aren't ready for estrus synchronization or breeding. You would do that scoring about 4 to 6 weeks prior to the start of your breeding season. Particularly if you bought heifers, this might alert you to really a problem in those heifers. One thing that could happen is if they were implanted at a young age, they may have really small reproductive tracts. Physically, they look large and ready to breed, but when you palpate that tract, they're just small. So it's a risk management tool for producers to use in their replacement heifer operation. You're probably going to partner with your veterinarian to assign those reproductive tract scores, and sometimes you find that there was a free martin in there that you didn't know exists. That male twin may have died in utero, but still went far enough to cause that free martin tract. So a good tool to check what's there. And the other thing we see is sometimes we learn we have a pregnant animal there too that we're trying to synchronize. So just a good risk management tool to palpate those prior to breeding and see which heifers are really ready.